Hi, are you a fan of salty foods just like me? Have you ever wondered how these industries manage to put the right amount of salt in each food packaging? Well, back titration is the answer. This is Daisy Nueva and welcome for today's video. To learn more about back titration, let's understand first what is back titration. Is back titration. Back titration is a process in which the excess of standard solution used to consume an analyte is determined by titration with the second standard solution. In contrast to direct titrations, where analyte A directly reacts with titrant B, back titrations are a subcategory of indirect titrations. During a back titration, an exact volume of reagent B is added to the analyte A. Reagent B is usually a common titrant itself. The amount of reagent B is chosen in such a way that an excess remains after its interaction with analyte A. This excess is then titrated with titrant 3. The amount of analyte A can be then determined from the difference between a simple analogy for back titration is presented. A child is sent into a candy store with a known amount of money in order to purchase a candy bar, and the cost of the bar is subsequently determined by counting the amount of change the child brings back. This is analogous to adding excess acid to a base and determining how much base was present by titrating the unreacted acid. The analogy is extended to illustrate what happens when an acidic or basic impurity is present in the system and is further developed to cover a situation in which the acid and unknown base reacts in a 2:1 ratio rather than a 1:1 ratio. Back titration is designed to resolve some of the problems encountered with forward or direct titration. Possible reasons for devising back titration techniques are: first, the analyte may be in solid form. Second, the analyte may contain impurities which may interfere with direct titrations. Third, the analyte reacts slowly with titrant in direct or forward titration. The reaction with the intermediate reactant can be speeded up and reaction can be completed, say by heating. Fourth, weak acid and weak base reactions can be subjected to back titrations for analysis of solution of unknown concentration. Recall that the weak acid and weak titration does not yield a well-defined change in pH, which can be detected using an indicator. Back titrations are mainly used in the following cases. First, if the analyte is volatile or an insoluble salt. Second, if the reaction between analyte A and titrant B is too slow for a practical direct titration. Third, if weak acid-weak base reactions are involved when no suitable indication method is available for a direct titration. Typical examples are complexometric titrations, for example, aluminum with beta. This direct titration is only feasible at elevated temperatures. However, adding EDTA in excess to aluminum and back titrating the residual EDTA with copper sulfate allows a titration at room temperature. This is not only true for aluminum but for other metals as well. A back titration is performed according to the following general principle. First, add reagent B in excess to analyte A. Second, allow reagent B to react with analyte A. This might require a certain waiting time or even refluxing, just like saponification value. Last, titration for remaining excess of reagent B with Titan 3. Be aware that since you are performing a back titration, the blank volume will be larger than the equivalence point or EP volume, unlike a blank in a direct titration. This is why the EP volume must be subtracted from the blank or the added volume of reagent respectively. Other examples include the saponification value and iodine value of edible fats and oils. For the saponification value, ethanolic POH is added in excess to the fat or oil after a determined refluxing time to saponify the oil or fat. The remaining excess is back titrated with hydrochloric acid or HCl. Process is similar for the iodine value, where the remaining excess of iodine chloride is back titrated with sodium thiosulfate. To summarize, back titrations are not so different from regular titrations, and the same general principles apply. The following points are necessary for a back titration. First, know the stoichiometric reactions between your analyte and reagent B, as well as between reagent B and Titan 3D. Know the exact concentration of your titrant E. Know the exact concentration of reagent B or carry out a blank determination. And lastly, use appropriate titration parameters depending on your analysis.